This video is considering resistors in series or in parallel and how we add those together. So if we have resistors first of all in series, we have to think about what we know about series circuit. So there should be two things. We should know that the current is the same everywhere. So the current here, if I just give a number to it, so let's just make it 5 amperes, will be the same here, will be the same here. It will be 5 amperes at every point, okay, because the current is the same everywhere in a series circuit. And we should know that the potential difference is going to be split evenly between the components. So those are the two things you should know, but the one that makes the most difference to us is the current. So if we think about our journey that our electrons have to travel on, we've talked about this being like they've got to overcome two hills. They've got to overcome the resistance and get past it, which is why the voltage is split evenly, assuming they're identical. So if I want to know the total resistance, I simply have to add together the resistance of each of the hills, effectively, or in this case, the resistance of each fixed resistor. So if I make this resistor 10 ohms, and I will make this also 10 ohms, then the total resistance is going to be R1, so I call this R1, and R2, both of which are 10, so 10 plus 10, which is 20 ohms. So this is our equation for resistors in series. The total resistance is equal to R1 plus R2, etc. So however many resistors, you simply add them all together, and there is nothing more complicated to it than that. Now in parallel, we have to think slightly differently. So in parallel, what we now know is that the current is split evenly between the components, but we also, assuming these are identical, so if we have R1 and R2, and we have an EMF that's going to be applied, and remember the potential difference would be the same, so if the EMF here was 10 volts, then this would be 10 volts and this would be 10 volts. Now, to explain where this comes from, if we know that the current, the total current in this circuit is going to be the current, so the total current I could measure here, for example, or I could measure it there, on the way out, is going to be the current that goes down path 1 plus the current that goes down path 2. So those have to add together to give me my total again. Now what we can do is we can apply Ohm's law, which is the equation that we have for resistance. So resistance is voltage divided by current, and we can rearrange this so that current is voltage divided by resistance. And what I can do is I can substitute Ohm's law into this equation. So if I want to know the total resistance, so if I want to know the total current, that's going to be the total potential difference divided by the total resistance, and each individual piece of current here is going to be the potential difference across path 1 and the resistance of path 1 plus the potential difference across path 2 and the resistance of path 2. And now because we know that the voltage at each point is the same, if that was 10, that would be 10, and that would be 10, the voltage here cancels out. And so the equation we're left with is 1 over the total resistance is equal to 1 over R1 plus 1 over R2. So this is the equation that we have for resistors in parallel, which you can see is a little bit more complex. But the best way to understand this is for me to just give you, is to use this very simple example. So if we know that the resistance of each of these is 10 ohms, then if I want to know the total resistance, so 1 over the total resistance is going to be 1 over 10 plus 1 over 10 which is going to be 2 over 10, or 1 over 5. And so my total resistance here isn't 1 over 5, which if I put that as a decimal, would be 0.2. That isn't my total resistance. This is 1 over my total resistance. So the last thing I have to do is I have to do 1 over 0.2, which will give me 5 ohms as my total resistance, as opposed to 20, which is what we had in the series case. And just to, you might be spotted that obviously when you do 1 over something, you basically flip the numerator and the numerator and the denominator. So the 5 effectively would go to the top, which is why you can see that. So that's another way of doing it. You don't have to necessarily go through the process of turning this into a decimal and then doing 1 over on your calculator. If you recognise, you can just swap that. Assuming that this is 1, of course. If that was a different number, then you would need to go through this process. So this is the equation. You'll practice this in class. The one last thing that you want to be able to think about this is what happens when you have a circuit that is both series and parallel. So I'm going to call this R1, R2, and R3. Now the way that you deal with this is simple. You pretend that this parallel combination here of R2 and R3 is just one resistor. So in terms of the way I'm going to view this, I'm going to pretend that I've got R1 and I've got another resistor in series to it, which represents this. So what I do first is I work out my resistance of my parallel part. So I'm just going to, for simplicity, make these all 10 ohm fixed resistors, because we've done the maths for most of this already. So if I wanted to know the total resistance for this, if I have two 10 ohm fixed resistors, I will do 1 over 10 plus 1 over 10, which will give me 2 over 10 or 1 over 5. So I do the reciprocal of that, which will give me 5 ohms. So the total resistance of this bit will be 5 ohms. This is 10 ohms because it's fixed, and so because they're now in series of each other, I just add them together. So my total resistance is 15 ohms. So it's important that you can add resistors in series and in parallel. You don't need to understand every aspect of how to derive this equation, but you do need to make sure you learn this equation for resistors in parallel, and this equation for resistors in series, and then you should be able to apply those to circuits where you have one or the other or both in conjunction. And if you're doing that, just remember, work out the parallel bit first and then just add the series bit to it at the end.